the values of the definite integral from 0 to 1 of x to the fourth times 1 minus x to the fourth, all of that over 1 plus x squared dx, is or are. And they say are because more than one of these might be the correct answer. This is one of those multiple correct answer problems. So this is just a straight up definite integral. And it looks like the best way to do it is really just expand out the numerator, see if we can simplify that with the denominator, and then just try to take the antiderivative. So let's do that. So first let's expand 1 minus x to the fourth. And when you're taking the binomial to the fourth power, to remember the coefficients, you of course can use the traditional binomial coefficients. But I find it easier just to use Pascal's triangle to remember what the coefficients are. So if you have a binomial, if you square it, the coefficients are 1, 1 plus 1 is 2, and then 1. And I've done several videos where I explain why this works. And if you take it to the third power, the coefficients are 1, 3, 3, and 1. I'm just adding the two branches that add up, that point to that one node there. I guess you could view it that way. And if you take it to the fourth power, the coefficients are 1, 4, 6, 4, and 1. So if we want to take 1 minus x to the fourth power, and I'm going to write it like this. I'm going to write it as negative x plus 1 to the fourth power. And I want to do it that way because I want the high degree x terms to be listed first. Then this is going to be, so you're going to start with this term at the highest power, and then this term at the 0 power, and then each successive term, this term is going to lower in power, and this one's going to go up in power. So it's going to be negative x to the fourth times 1 to the 0. I'll just write it here, times 1 to the 0, plus, the coefficient of that first one was just at 1, so plus 4 times negative x to the third times 1 to the 1 power, plus, now we have our 6, plus 6 times negative x squared times 1 squared. Or another way to think about it is the exponents on the 1 and the negative x should always add up to 4. And then you have plus, now we're at this 4, plus 4 times negative x times 1 to the third, and then plus 1 to the fourth power, or negative x to the 0 times 1 to the fourth, which is really just 1 to the fourth power. So this is going to simplify to, so negative x to the fourth is the same thing as x to the fourth. Negative 1 to the fourth is just 1 times 1 plus, well, actually I should say minus, because negative x to the third is negative x to the third. So this is minus 4x to the third. So we've done that term. This term will become positive. Negative x squared is the same thing as x squared. So it's plus 6x squared. And then this is negative 4x plus 1. Now, we want to multiply this whole thing that we just expanded times x to the fourth. So let's multiply that whole thing times x to the fourth. So the expression x to the fourth times 1 minus x, all of that to the fourth power is going to be equal to, we'll just multiply this times x to the fourth. That's pretty straightforward. It's going to be x to the eighth minus 4x to the seventh plus 6x to the sixth minus 4x to the fifth plus x to the fourth. Now, we want to divide this bottom expression into the top expression. So we can just use some algebraic long division. So we want to divide, and I'll write it as x squared plus 1. We want to divide x squared plus 1 into this big thing, into this thing right here. So let me copy and paste that. We want to divide it into this, and we're going to break out some algebraic long division to do it. So let me draw the division symbol right over there. And so we just say, we look at the highest degree terms on every step. X squared goes into x to the eighth, x to the sixth times. So we put in the x to the sixth place. X to the sixth times x squared is x to the eighth. X to the sixth times 1 is x to the sixth. And then we subtract this from the number up here, the expression up here. X to the eighth minus x to the eighth is nothing. Negative 4x to the seventh minus nothing is negative 4x to the seventh. 6x to the sixth minus x to the sixth is plus 5x to the sixth. This, and then these you're subtracting nothing from them, so it's minus 4x to the fifth plus x to the fourth. Now, x to the squared, or x squared, goes into x to the seventh, or it goes into negative 4x to the seventh, negative 4x to the fifth times. Negative 4x x to the 5th times. Let's scroll down a little bit. Negative 4x to the 5th times x squared is negative 4x to the 7th. Negative 4x to the 5th times 1 is negative 4x to the 5th. Now we subtract this from that. These cancel out, and we are left with 5x to the 6th plus x to the 4th. X squared goes into 5x to the 6th. 5x to the 4th times. So plus 5x to the 4th. I just arbitrarily switched colors. The yellow is becoming monotonous. 5x to the 4th times x squared. Scroll down some more. 5x to the 4th times x squared is 5x to the 6th. 5x to the 4th times 1 is 5x to the 4th. 5x to the 4th. And now we subtract, or we just subtract, those cancel out. X to the 4th minus 5x to the 4th is negative 4x to the 4th. Nothing to bring down. X squared goes into negative x to the 4th. It goes into it negative 4x squared times. Negative 4x squared times. Negative 4x squared times x squared is negative 4x to the 4th. Negative 4x squared times 1 is negative 4x squared. And now we subtract that from that. You subtract this from 0, or 0 minus negative 4x squared is going to be positive 4x squared. Positive 4x squared. All of these steps we're always subtracting. I should draw the subtraction symbol right over there. And then x squared goes into 4x squared. We're in the home stretch. It goes into it 4 times. So plus 4. 4 times x squared is 4x squared. 4 times 1 is 4. And then we subtract one last time. We subtract this whole thing. These cancel out, and then we're just left with a remainder of negative 4. So this whole thing, this whole expression over here, simplifies to this plus negative 4 over x squared plus 1. Let me rewrite it. Let me copy and paste it. So it turns into this. So copy, and then let me paste it down here. I wasted a lot of real estate. Paste. So it turns into this, and then we have the minus 4 over the x squared plus 1. So minus 4 over x squared minus 4 over x squared plus 1. So this is the entire expression that we have inside of the integral. So this is the same thing as the integral of this from 0 to 1 times dx. So now we just have to take the antiderivative of this, and this looks pretty straightforward. The only kind of complicated part is this right here, but you might recognize that the derivative with respect to x of arctangent of x is equal to 1 over x squared plus 1. So that kind of simplifies this part for us. So let's tackle the problem. So let's just take the antiderivative. This is pretty straightforward. Antiderivative, we just have to make sure we don't make a careless mistake. Antiderivative of x to the 6th is going to be x to the 7th over 7. I mean, I should say 1/7 x to the 7th. Antiderivative of this is negative 4/6, which is the same thing as negative 2/3 x to the 6th. Antiderivative of that is x to the 5th plus x to the 5th. Right? I'm just raising the exponent. So that's where I get the x to the 5th, and then I divide by that exponent. So 5 divided by 5 is 1. And then I have x to the 3rd, or it's negative 4/3 x to the 3rd, negative 4/3 x to the 3rd, plus 4x, and then minus 4 arctangent of x. Arctangent of x. So let's think about this a little bit. So we're going to evaluate it at 1, and then subtract from that, it evaluated at 0. So we need to evaluate this at 1, and then from that, subtract it at 0. So if you evaluate it at 1, you have 1/7 minus 2/3 plus 1 minus 4/3 plus 4, that's plus 4 right over there, and then minus 4 arctangent of 1. Minus 4 arctangent of 1. So let's think about what the arctangent of 1 is. So the arctangent of 1 is essentially saying if I have a right triangle, if I take the opposite over the adjacent, so the opposite is telling us that so the tan, so it's telling us give us the angle. So we're looking for this angle. We're looking for the angle where the tangent of this angle is equal to 1. Or another way to say it is that the opposite over the adjacent is equal to 1. Or another way to say it is that the opposite is equal to the adjacent. The opposite is equal to the adjacent. So this side has to be equal to this side. This is going to be a slope of 1 right over here. Now, we could, try to look at, different types of triangles, and it might pop out at you what kind this is, but you could just go to basic geometry to think about this. This is a right angle right here. These two sides are equal. These two angles are equal. So these two angles have to evenly split the remaining 90 degrees in the triangle because it adds up to 180. So this is a 45 degree angle. But in general, when they don't tell you whether you're in radians or degrees, at least on most exams I've seen, you should just assume that you are in radians. So 45 degrees is the same thing. Let's see, pi is 180 degrees. Pi over 2 is 90 degrees. Pi over 4 is 45 degrees. So this is equal to, that right over there is pi over 4 radians. So this over here is pi over 4 radians. Or I could just say pi over 4. Or another way to think about it, tangent of pi over 4 is equal to 1. So this is just the inverse function. So these two cancel out. So this simplifies to, so I just evaluated it at 1. So let me, before I move forward, let me subtract from that this whole thing evaluated at 0. And this is a little bit more straightforward. All of these things are going to be 0 when you evaluate at 0. And what's the arctangent of 0? Well, tangent of 0 is 0. If this angle was 0, if you just had a flat line, then your slope is flat. So this is just going to be 0. So this whole thing evaluated at 0 is going to be 0. So the whole value of our definite integral is going to be this thing over here. So it's going to be all of this stuff, and then this last term right over here, is negative 4 times pi over 4. So it's going to be negative pi. And all of these are going to add up to some number without a pi in it. So if you are under time pressure, it's actually a good idea to just look at the answers before we even add up all of those fractions and say, which of these have a negative pi in them? And only one of them has a negative pi in them. So our answer is most probably going to be this. If you're under time pressure, I would just circle that. It's clearly not any of these. None of these have a negative pi in them. And there's no way that that negative pi can get altered by this stuff over here. So you wouldn't even have to worry about adding it. But since we want to make sure we have the right answer, let's add up all of these fractions. So let's think about what we can do here. So if we have, let me try my, so let's see, negative 2/3 minus 4/3. Let me take those two terms. Negative 2/3 minus 4/3 is negative 6/3, or negative 2. So those become negative 2 plus 1 plus 4. So plus 1 plus 4, and then plus 1/7. Plus 1/7. So this is 3 plus 1/7. 3 plus 1/7. And of course, we have the negative pi out there, minus pi. And this is the same thing as 21 over 7 plus 1/7 minus pi, which is equal to 22 over 7 minus pi. So that is indeed the only answer, 22 over 7 minus pi. And we're done.